Hello. In this video, we will learn how to log, plot, and evaluate RS232 output of EULER-NAV Miniature Baro-Inertial Attitude and Heading Reference System. In this tutorial, we will carry out the following steps. At first, we will connect the device to PC's COM port via RS232 to USB adapter. Then we will power on the device. Afterwards, we will log COM port data with real-time. You can download it under the provided link. Finally, we will take the recorded binary file and plot the data in Octave. The evaluation scripts that we will be using today are provided in our GitHub repository. Let us quickly click on the link and learn where in the repository the scripts are stored. Clicking on the link brings us to BHRS OSS repository. Then, if you go from the root folder to project and BHRS evaluation tools, we will land in this folder. And in this folder, there is a script called script evaluate bhrs.m. This script can be launched in Octave or in MATLAB. Today, we will use Octave. Now, let us switch to the practical session. At first, take a look at the setup we will be working with. Here we have EULER-NAV Baro-Inertial Attitude and Heading Reference System connected to a PC via a COM port. This black box is our Attitude and Heading Reference System, and these two connectors are RS232 to USB adapter. Before we connect to the test PC and start recording, let us review COM port settings required for successful login. Baro-Inertial Attitude and Heading Reference System uses 115,000 bits per second baud rate, word length 8 bits, no parity bits, and 1 stop bits. If you forget these settings, you can always look them up on the official documentation page. The URL is provided on the slide. I have connected to the remote test setup. Let us power on the device and start real-time. I will power on the device by double-clicking on a batch script that controls laboratory power supply. Now the device is on. Let us see what real-time shows to us. Once we open real-time, we already see that some COM port is open, and by chance, it was exactly the COM port that our Baro-Inertial Attitude and Heading Reference System is connected to, and we already see that data is being sent, but the COM port indicates error state. This is because default baud rate setting of the real-time is not correct. Let us take a look. By default, real-time opens COM port with the baud rate settings 57,000. As we know, Baro-Inertial Attitude and Heading Reference System requires 115,000. Let's change the setting and verify that once the setting is changed, COM port will be in normal state. We've changed the baud rate, and now we see that data reception is being performed correctly. Real-time has got several handy features. First of all, we can represent this byte stream in a bit nicer manner. For that, go to Display, select hex format, then New Line, switch to Sync to be a number, and then type the magic symbols. We will use 0x for E and 0x for 5. These are sync chars that are used in the serial protocol of the Baro-Inertial Attitude and Heading Reference System. If we go a step further, we can type the protocol version and the message number of interest. 0x02, 0x00 is the latest protocol version, and if we are interested in inertial data messages, we need the message ID 0x01. Change. Now we see that we are receiving about 200 such messages per second. This is indicated by the increasing counter of matches. Okay, we are receiving the data. Let's now record it. To capture data, go to the Capture tab, set up the file to record to. I will call it capture_data. 1.binary, click Save. I want to record the data right after power on, so I will power off the device. Then I will click Start Override and power on the device again. We see that now real-time is in recording state, and in several seconds, received byte count will go up. It means that data is being streamed and logged to the file. Let's wait some minutes to collect enough data for evaluation. Okay, we have collected enough data. Let us stop recording and power off the device. Now I will open Octave and show you how to plot data that has been recorded. I'm starting Octave. It takes several seconds for Octave to load. Great. Now I need to open the folder where the evaluation script is located. For that, I click Browse. Then I go to the root folder of the cloned repository. Then I am navigating to Projects, BAHRS Evaluation Tool, and click Select Folder. In this folder, we will find the script with the name script_evaluate BAHRS. Let's click on the script and it will open. The script is fully functional. It means that it can run without any issue right after download. Let's click on the play button. Octave has plotted several figures for us. For example, angular rate data, specific force data, attitude angles, pressure height, and vertical speed. Let me close all those windows. Without modification, the script evaluates the HRS log file that's provided in the repository as a sample. It's not the data that we have just recorded. Now let us plot data that we recorded together several minutes ago. I copied this data into the root folder of the cloned repository. Recall, the file name was capture_1. To plot data that we recorded together, I need to substitute this file name with the path to the file we recorded. I can copy this. Then erase the file name and type capture_1.binary. Now I will click on the play button and Octave will show me the new plots. Plots are ready. Let's take a look at them. Here we see angular rate and specific force output. Altitude and attitude angles. Please note that open source software does not provide magnetic heading, and if you record output of Baro-Inertial Attitude Heading Reference System that is running open source software build, then this third plot will be empty. On the right, you see pressure height, downwards velocity, roll angle, pitch angle, and magnetic heading. Let us now explore one cool feature of the evaluation script. At first, the script converts binary file into MAT format, and then it creates plots. It literally means that data can be directly analyzed if you want to. Let us clear the workspace and double-click on the MAT file that was created by the evaluation script. For us, it's capture_1.mat. Double-click on it, and Octave will load the content of this MAT file into the workspace. And in the variable explorer, you will see structures that contain different message types sent by the Baro-Inertial Attitude and Hiding Reference System. For example, we have here a struct with navigation data messages, struct with inertial data messages, and so on. Those messages are aligned with the serial protocol of the Baro-Inertial Attitude and Hiding Reference System. Let's take a look at one of them. For example, navigation data message. It has several fields: validity, magnetic heading, pitch, roll, velocity, and height. Note that it's encoded exactly as it is in the output protocol. So roll and pitch are not decoded, meaning that they are 16-bit integer values, not floating point numbers. You can further double-click on data and probably plot it if you want. I've plotted validity of navigation data. Validity is a mask indicating which of these fields are valid. We see that validity is 31 several seconds after startup, and 31 means that all the fields are valid. This is actually an expected result. Thank you for your attention. This is all for today. See you next time.